Here we have a SAT math problem. Okay, let's go to the question. In right triangle ABC above, AD equals to 10 and BC equals to 25. If the value of sine angle BCD is 0.6, what is the area of triangle BCD? Using the given information, we have to find the area of this triangle BCD over here. For this triangle BCD over here, this perpendicular line BA represents a height and this CD represents the base of the triangle. Okay, we know the formula to find area of a triangle, that is 1/2 times base times height. Okay, here once I get the length of this line segment CD, that we can plug in for B, that is a base. And once we get the length of this line segment AB, that's the height of this triangle BCD, we can plug in for H and we can get the area of this triangle BCD. Okay, how do you have to get the height AB and the base CD of this triangle BCD? For that, we can consider this particular piece of information, that is sine angle BCD is 0.6. Let me write this up over here. Sine angle BCD equals to 0.6. Okay, we can write this 0.6 as a fraction, as a 6 over 10. Okay, so here 2 goes into 6 3 times and 2 goes into 10 5 times. I am getting 3 over 5 as a value for sine BCD. Actually, the angle BCD is over here, because here we have BCD, D is over here. So this is the angle BCD. And when I consider this interior angle measure over here, in this right triangle ABC, the side AB, which is opposite to this interior angle BCD, is called opposite side. This AB is opposite side. And so this is hypotenuse because it's opposite to the right angle in this right triangle ABC. So this BC represents hypotenuse. Okay, according to Secreto, so we have the formula for sine, that is opposite side by hypotenuse. So the number we have over here, that is 3, is corresponding to opposite side and this 5 is corresponding to hypotenuse. From these two numbers 3 and 5, if I want to get the actual length of opposite side and hypotenuse, I have to multiply these two numbers by the same non-zero number, say x. That is, when I multiply this 3 by x, I am getting 3x. 3x is the actual length of opposite side. And when I multiply this number 5 by x, I am getting 5x. This 5x is the actual length of hypotenuse. So here 3x is the actual length of opposite side, that is the length of AB. And 5x is the actual length of hypotenuse, that is the length of the hypotenuse BC over here. But already we have the length of the hypotenuse BC, that is 25. So that is, this 5x over here must be equal to 25 because both of them represent the same stuff, that is the length of BC. So 5x equals to 25. So when I divide both sides of this equation by 5, I am getting x equals to 5. Okay, here I got the value of x, that is 5. Now I can plug in x equals to 5 over here. When I plug in x equals to 5 over here in this 3x, I am getting 3 times 5, that is 15. Okay, here I got the length of the side AB of this right triangle ABC, that is 15. Actually, this 15 is a multiple of 3, so we can write this one as 3 times 5. And here, when I consider the length of this hypotenuse BC, that is 25, it is a multiple of 5, that is, it can be written as 5 times 5. Okay, here in this right triangle ABC, so the length of this side AB is a multiple of 3 and the length of the hypotenuse BC is a multiple of 5. And in both the multiples, we have the same factor 5. So this ABC is a 3, 4, 5 right triangle. That is, the length of the hypotenuse is a multiple of 5 and the length of one of the other two legs is a multiple of 3 with the same factor 5. Then the length of the third leg has to be a multiple of 4 with the same factor 5. So that is, the length of this AC over here has to be 4 times 5. So 4 times 5 is 20. Okay, here I got the length of this side of the right triangle ABC, that is AC. The length of AC is 20 and already we know the length of AD is 10. Then what is the length of this DC? So to get the length of this DC over here, we have to subtract the length of AD 10 from the total length AC 20. When I subtract this 10 from this 20, I am getting 10 as the length for this side CD of this triangle BCD. Okay, anyways, so for this triangle BCD, I got the base, that is 10, and already I got the height, that is 15. Okay, now let's get the area of triangle BCD. Let me write it over here. Area of triangle BCD equals to 1/2 times the formula base times height. Okay, here 1/2 times the base of the triangle is given by the length of the line segment CD over here, that is 10. We can plug in 10 for B, and height of the triangle BCD is given by this line segment, the length of this line segment AB. So that is 15. We can plug in 15 for H. Okay, here 2 goes into 2 1 times and 2 goes into 10 5 times. Okay, when I multiply this 1, 5 and 15, I am getting 75. Therefore, the area of triangle BCD is 75 square units. We find this 75 in answer choice B. The correct answer choice for this question is B.